Hi, I'm an old guy and I do maths. We have to graph the derivative of this function. Well, let's find the derivative of this function and see what we can do. So, there we are. That is the derivative of this function. Probably not a function that you're used to seeing. And given that the instruction is to graph this, it might be possible to put some values into it and find what this thing looks like approximately. That's what we're trying to do here. However, there may be another way, and to do that we need to consider the graph of this function. And this is very roughly what it looks like. It looks like this. And those of you familiar with the inverse of this, which is that, might recognize this shape. Now, this has a longer, flatter area in here than, say, this graph. Now, with that information, we can draw an approximation of the graph of the derivative. Now, the graph of the derivative is a graph of the gradients of this function. And what do we know about this? Well, we know, despite my poor drawing, that the gradient here is very steep and gets shallower and shallower and shallower, but it never reaches a flat line, a horizontal line, so it never goes to zero. So we're probably looking at the x-axis as being some sort of an asymptote. In here, at zero, we have a point of inflection where we have a gradient, or rather our graph goes straight up. And we know that gradient to be undefined. So what we know is that this thing won't touch the y-axis. The graph of the gradient won't touch the y-axis, but indeed it is very, very steep here, and it's positive. And what happens is, as we move up here, it gets shallower. And so the graph of the gradient function for this part of y equals x to the power of 1 over 5 looks like this. Correspondingly, this part of it looks like this, and the y-axis is an asymptote and the x-axis is an asymptote. And that is how you figure out what the graph of the derivative of this function looks like. Now, you can put values into that, and you'll probably need a calculator to do that, to get some points so that you can graph this more precisely. But what we're looking at when we look at the graphs of derivatives is we're looking to see how the gradient is represented graphically as it changes over time, over the x-axis. And this is how we do it. So I hope that this was interesting and useful. And if it was, please like and subscribe, and I'll see you next time. Bye.